Alright, welcome. Today we'll be talking about inequalities in two triangles. And first off, I wanted to talk about the hinge theorem. Okay, so the hinge theorem is this. So if we have two triangles, pretty simple stuff. Okay, and we know that these two are congruent sides and these two are congruent sides as well. This should just have, let me move this little guy off. Delete that. Boom. Okay, so if these two are there, all right, and then we have these angles in here. Okay, and let's call this angle A, B, and then let's call this side C, or this angle C, and then this is D, E, and F. Okay, so the hinge theorem actually states that if angle A is greater than angle D, then BC is greater than EF. Okay, so that's the hinge theorem right there. So in other words, just talking about what we were talking about in the inequalities in one triangle theorem, basically this side has to be bigger than this side because this angle is bigger than this angle, and you also need to know that these two sides are congruent for that to work. And also the converse is true. So in other words, if you know the two sides are, if this one's bigger than this one, then this angle is bigger than this angle. So the converse is also true as well. Now, what if we actually had some measurements? Let's say that this was 15 and this one was 6. Okay, and then let's say that this was 4x and this one was 2x minus 7. Okay, something like that right there. Okay, now what we would do is we'd probably use the converse to set this up. So the converse is that we would say, okay, since this 15 is bigger than this 6, then this angle has to be bigger than this angle. And I can set up an inequality that way. So 4x is greater than 2x minus 7. Okay, first off, I would minus the 2x from both sides, so I'd get 2x is greater than negative 7. Okay, and then I would get x is greater than negative 7 halves. So that's pretty simple right there. So that's x. But what possible values could I actually have here? Well, I would actually need to have a measurement value here. So let's say that this was 66 degrees. Okay, so what I would need to do is figure out, okay, what kind of values would I actually set up into here? So I'd need to start this problem over again and replace this 4x with 66. Okay, all right, so I'd add that, so I should get, what is that, 73? Yep, 73 is greater than 2x, and then I would divide both sides by 2, and 73 divided by 2, 36.5. Well, no, that would actually, yep, that would be greater than x. Okay, so x would have to be greater than 36.5. Okay, so what values could I actually have in there? So if I had 36.5 in here, this, well, actually I couldn't plug in 36.5, I could plug in 36.4. So if I plugged in 36.4 into here, I would have to times it by 2 and then minus 7 to get to be below 66. And let's actually try that out. 36.4 times 2 minus 7, and that would be 65.8. And obviously you could get really close to it. Okay, so we would say 60.58 degrees. Now, what number could we absolutely go down to? Now, if we had to get a range of answers of what it could be. So this is typically a problem that looks like this, except you actually will be given a problem that has the question mark. So how do we find that range? Well, we know this has to be below 66, but it also has to be above 0. Okay, but what does x have to be to get 0 degrees? Like let's say 0.1 degrees. Okay, what does x have to be? So we actually have to figure that out. So what we're going to do is set this greater than 0. So 2x minus 7 is greater than 0. Okay, we know it has to be greater than 0. So what we do is we go ahead and solve for 0, or we solve for this, and so 2x is greater than 7, and so x has to be greater than 3.5. Okay, and you could also check that out. So you would go 3.5, well, you need to be greater than 3.5, so let's go 3.6 times 2 minus 7, and that should get us about, I believe, not 0.1, but about, I believe, 0.2. Okay. All right, and so that gets us really close to it. So this, we could replace this question mark. We could replace this question mark with 3.5. So our x has to be greater than 3.5, but it has to be less than 36.5, and those are our ranges of answers. And that's how you work with the problems that look like this. Instead of setting them up in equal signs, you set them up with inequalities, okay? All right. And that is pretty much it for inequalities inside of triangles. Just make sure that you know the hinge theorem forwards and backwards, and you should be set, okay? Thanks.